We are just a little bit behind, so I'm going to run through the next two presentations relatively quickly. Again, a lot of the concepts in them we've already gone through, and this is more of a review. So this presentation really jumps into the concept of risk. One of the things we haven't talked about very much, under NI 51-101 in Canada, if you're going to disclose contingent and or prospective resource volumes, they require that you disclose the risk volumes. So after you've calculated the total amount of contingent or prospective resources, you have to quantitatively estimate the risk associated with the contingencies, and in the prospective resource case, the chance of discovery. So there's some mixed feelings in the Canadian valuation world whether it's useful to actually quantify the risk numbers because they are highly subjective. So when companies are required to disclose risk contingent resource volumes, we see a wide range of risks that's the argument is it's no more useful than simply subclassifying by the maturity subclasses. So a couple slides in, you'll see the box again with the maturity subclasses. And those maturity subclasses really give you a qualitative assessment of the risk of those volumes. So you know the volumes at the bottom of the project maturity subclass are the highest risk volumes, and you know the contingent development pending are the lowest risk volumes in the resource buckets. So qualitatively, you've already assessed the risk, but NI takes it a step further and requires that you quantify the risk by applying a risk factor. So that's basically what a lot of this presentation focuses on, and it's just going to show you that you can very quickly get some very low multipliers or very high risk factors that have a significant impact on your risk versus unrisked volume. So I'm going to skip through most of the resource definitions. We've seen them quite a few times. We're going to talk about how to risk resources, data availability, and then wrap up the short presentation. So the McKelvey box again. Very familiar with this by now. Our lowest volume, highest certainty over here. Highest volume, lowest certainty on the right, and highest risk on the bottom, lowest risk on zero risk in terms of the same decision tree we saw a couple times on day one. You start with your petroleum in place. You determine if it's discovered or undiscovered, recoverable or unrecoverable, and then commercial or subcommercial. So this is what I was just talking about with the project maturity subclasses. So the intention of these subclasses is to give users an idea of the risk level associated with volumes. So we know qualitatively that prospective resource volumes in the play category are less defined and therefore have a higher risk than prospects. And we know that development non-viable has a higher risk of being subcommercial than development pending contingent resources. So if you're using probabilistic methods, you're gonna have probabilistic distributions for every parameter in your evaluation. This table is just showing you, it's talking about volumetrics and recovery factors, so it's determining recoverable volumes based on a probabilistic method. It's showing you a summary of an example of P90, P50, and P10, so low, best, and high statistical points for parameters such as area, pay thickness, porosity, LSAT. So every parameter that goes into the volumetric calculation has a full distribution of potential values when you're doing a probabilistic evaluation, which is why you have to use a computer software, something like a Monte Carlo simulation, to generate these millions of potential values and then put them in a distribution so you can pull the P90, P50, and P10 values. One other concept that, again, I'm not going to go into too much, but you can see that almost all the parameters in oil and gas follow a log normal distribution. So there's a few different types of distributions. And in general, if you're unsure, a good rule of thumb is that most oil and gas properties follow a log normal distribution. So it's showing you, it ran through the calculations. They've done their Monte Carlo simulation on all the different properties based on the data they have. They've come up with an OOIP of 3.2 million in the low case and 113 million barrels in the high case. So you can see there's a very wide spread. So this is a very poorly understood reservoir. There's very little data. This is probably something like a prospective resource reservoir that's all we can see is seismic accumulation that hasn't been determined. So we're estimating a bunch of these parameters from analogs or other areas. So we have a reasonable range for each, but we have no set values. And recoverable oil based on 30, 40, and 55% recovery factors, which is quite high for oil. Less than 1 million barrels, 6.5 million, and 62 million barrels. The contrast to that is deterministic methods, where you have a set value, one discrete value for each parameter. In general, in practice, when we're using deterministic, you could have a range of OOIPs. You could still have an uncertainty range on most parameters, but generally speaking, when we're doing evaluations, we will choose one OOIP, and then we will apply our uncertainty range to the recovery of that OOIP. So generally, we won't have 3 different net paying maps. We won't have 3 different porosities chosen. We'll have the same geological parameters or inputs, and we'll come up with a single original oil in place as a discrete value, and then we'll apply a range of uncertainty to that single OOIP, which is the same recovery factors you saw in the probabilistic. And so you can see there's a much smaller spread. So in the probabilistic case, we have 1 million barrels to 62 million barrels recoverable. And in the deterministic case, we have a range of only about 9 to 17. So it's a much tighter spread. So in general, that's telling you that when you're comfortable enough to move to a deterministic approach, you're going to have a much higher certainty in the data. So we've talked about risk in the various categories: chance of discovery, estimated probability is that when you drill a well, you're going to find a significant accumulation of potentially recoverable petroleum. Chance of development, the chance that it'll be commercially developed, and chance of commerciality is the product of the two. So again, prospective resources has both. Contingent resources has chance of development, and reserves, the chance of commerciality is 100%. So when we start with chance of discovery, we start to actually look at, if you have to quantify the chance of discovery, when you're doing a geological assessment, the main risk factors you're going to be looking at are the source, the reservoir, the trap, the seal, the timing, and the migration. So these are all the components that go into an oil and gas accumulation. These are all the things that have to be present in order to have an oil and gas reservoir. There's a little chart on the right that has a whole bunch of different arrows I should say, that just talk about the range of risk values based on things like bad news, good news. So it's talking about as you get more data around a given reservoir accumulation or well, you move through this chart. So if you get good news from a well, you're going to start to move to the more likely or the lower risk. When you get bad news, you're going to have a higher risk value. As your data quality and data quantity increases, again, you're going to have a higher level of certainty as long as it's good data. So there's basically, as you get more data on accumulation, you're either going to go up and to the right or up and to the left, depending on whether it is indicating good news or bad news. So the reason that risk factors can get so, you can have such high risk factors or such low multipliers very quickly is just because they're multiplicative. So you may have no risk of a number of these, but if you have 2 or 3 factors that are less than 1, you have to multiply all those factors together, and as soon as you do that, your numbers drop, your risk factor increases exponentially. This presentation focuses on 2 example cases. So in the first case, you have a fairly high certainty of almost every piece of the puzzle. You have a 90, you only have a 10% risk of not having a source rock. You have a 70% risk of reservoir being present, 80%. So you can see everything is between 70 and 90%. So you have a fairly high level of confidence in these things. But when you get to your total risk factor and you multiply all those confidence levels together, your risk factor is 0.2. So you have an 80% chance of hitting that. In case 2, again, you know there's a source rock. There's a 100% chance you're going to encounter a source rock. You know the reservoir is present. You know that you have a trap, and you know you have a seal. And the only thing you're uncertain of is whether there is a reservoir, whether you have the proper timing for oil and gas migration, and whether you've actually achieved that migration. So you only have 3 out of 6 factors, and you're still down to a 73% chance of success. So it's just showing you that as soon as you have uncertainty in more than one category, your risk factor increases dramatically. So moving away from chance of discovery and into chance of development, so same thing. These are the contingencies that we talked about. These are the things that can prevent you from having a commercially viable project. So legal, regulatory, market access, political, social license, corporate commitment, and development time. These are all identified in the resources other than reserves guidance in Rotor, and they're also mentioned in the RMS. So again, same case 1, same case 2. So this example is just flowing through case 1. Again, you have high confidence on almost everything, but you have 4 factors that are less than 1, and you're down to a 58% chance of development success. Case 2, you have a lot more data, you have a more defined project plan, you have things like your legal processes in place, you know you have market access, the government's on side, you have corporate commitment, and you know your development timing, and you still only have an 81% chance of commercial development. So what happens with prospective resources is you have to multiply the chance of discovery and chance of development to get the chance of commerciality. So this is your total risk factor for those resources. So if I had a seismically defined accumulation and I had come up with those volumes either probabilistically or deterministically, if it was seismically defined, it would have to be probabilistically. So if you went back to that first slide where I had a range of 1 million barrels recoverable to almost 70 million barrels recoverable, this is what I would have to apply to those barrels to count them as risk volumes, so taking into account all of the risk factors associated with those volumes. So when I go through that exercise, and I think the next slide is going to show you, I have to multiply, I can only take 12% of my probabilistically determined volumes and say that they're risk. In case 1, and in case 2, I can only take a little less than 60%. This is outlining how big of an impact it can have. So if you assume, for whatever reason, you had run your economic calculations on those original probabilistic volumes, and you had determined that you had roughly $100 million of unrisked value, in case 1, the risk value that you'd be able to disclose would only be $12 million out of that $100 million. In case 2, which we were virtually certain, we were 100% certain that probably 10 out of 15 factors that need to be there were there. We're still only going to have 60% of that value that we can disclose. So data availability for the different types. For the different volume buckets, what's usually available? Reserves, you basically have everything by the time you get to reserves. You may or may not have seismic coverage, just depending on the type of play. You're going to have well logs. You're likely to have some sort of core analysis in the area. You're going to have delineation wells, pilot results, development, production history, lease operating statements. You've got the whole suite of data. Contingent resources. You're usually going to have a fairly well-defined project for contingent resources, so everything that goes up to the pilot level is generally included in contingent resources. And prospective resources, if you're lucky, you'll have the 3 that they have listed there. They're basically saying what's the maximum you can have in each category. So coming out of this, again, the major conclusion out of this is when you're incorporating risk factors, the effect of multiplication has a huge magnifying effect on risk, and because of that, it's very challenging to determine appropriate risk factors. So when NI 51-101 required judges and evaluators to disclose quantitative risk numbers, a lot of people were saying, does this make sense? Or are we better off just using the qualitative descriptors that in a sense tell investors and users how risky the volumes are, but don't try to put arbitrary percentages on that can have wildly different impacts on the volumes disclosed. So like I said, it's a fairly quick, it's kind of an offshoot. You probably won't deal a lot with risk. The bigger thing in this is if you're going to implement your own disclosure guidelines, both COBE and PRMS talk about this, but generally speaking, unrisked volumes that are properly categorized into the maturity subclasses are probably a better way to go because risk factors are very subjective.